Hello, we're back for the second part of lesson 2-3. And the title of the lesson is 88 miles per hour. We just did some unit rates and scaling up and scaling down. And now we're going to add that in with what we've been learning about linear equations. So according to taxfarefinder.com, a cab ride from the airport in Las Vegas will cost you an initial charge of $5.10 plus $2.60 per mile. Use this information to fill in the rest of the table describing the total cost for various distances. Then create a scattergram using the distance as x coordinate and the cost as y coordinate. So we're going to do a little bit on here, but then I'm going to suggest we move to Desmos so that we get practice there. So our initial cab ride was $5.10, and then we're adding 260, adding 260, adding 260, which would get us to $12.90, and adding 260 would get us to $15.50, and adding 260 would get us to $18.10. And then we're going to go ahead and plot these on our graph. So let's plot a few by hand. So at $0, we were just above 5, which is just about halfway between 4 and 6. And then at 1 mile, just starting out, we were at 5.10. At 1 mile, it's going to cost us almost $8. And then at 2 miles, just over $10. At 3 miles, it's going to cost us $12.90. So just over 12. Almost to the middle here, 13. $4 is going to be $15.50, so that's going to be right here. And 5 miles, we said $18.10, so just above 18. Okay, it says, what do you notice about the pattern that the points on your scattergram are making? Use that observation about a pattern to connect the points. Draw a graph that represents the cost of a cab ride based on distance. So appear linear. And we can see that if we connect the dots, they should make a line. Now, Mrs. Main's drawing is not perfect. We know that. Okay. This one shouldn't be about right there. It says the points where any graph crosses the y-axis. This is our y-axis right here. Is called the y-intercept for the graph, and a point where the graph crosses the x-axis is called an x-intercept. Write the coordinates of the y-intercept for the graph that you drew. More importantly, what information does the y-intercept represent? Does the graph have an x-intercept? Why or why not? So our y-intercept is right there. So the y-intercept is at the coordinate point 0 for x, and y is at $5.10. So we always call the y-intercept our starting value. Now the x-intercept would be if we were going to cross the x-axis, but it's only getting bigger. So we know that we're not going to cross the x-axis going this way. And we'd have to cross the x-axis if we went back this way. That means we'd have to go a negative distance. So let's just make a note. No x-intercept, because we cannot go a negative distance. Number 4 says, how much more will you pay for a 3-mile ride than for a 2-mile ride? So a 3-mile ride is $12.90, and a 2-mile ride is $10.30, and it should come out to be the $2.60, which a note for yourself is a lesson check. $2.60 is what we're increasing from mile to mile to mile, because we all have to pay that $5.10 as an initial charge. How much more will you pay for a 5-mile ride than a 2-mile ride? Explain why that makes sense based on your answer to question 4. So 1 additional mile costs $2.60. And that means if we're going 3 additional miles, 5 minus 2 miles is 3. So 3 miles times the $2.60 per mile says that our additional cost should be $7.80 to go from mile 2 to mile 5. And if you add $10.30 and add $7.80, you would get to $18.10. Okay. So number 6 says, pick any 2 points on the graph that you drew and subtract the second coordinates. Then divide the result by the difference of the first coordinates. Each person in your group should pick a different pair of points. What does the result represent about the cab ride? So I'm going to pick point 1 and 4. So mine are 1 and 4. So 1 mile was 770. And 4 is 1550. So we are going to, it says, subtract the second coordinate. So that means I'm going to subtract 1550 and subtract 770. Then divide by the result by the difference of the first coordinate. So if I subtracted 1550 minus 770, I should probably start with 4 and subtract 1 so that my coordinates line up. 4 goes with 1550 and 1 goes with 770. So 780 divided by 3 is $2.60. And we have to remember that miles are the units on bottom. So that is $2.60 per mile. And what does it represent? It represents that constant change, right? So when we put this together for our formal linear equation, this is going to be called our slope. Our slope is the constant change. And formally down here, it is the difference of the second coordinates divided by the difference of the first coordinates. Or you could call them y2 minus y1 over x2 minus x1. Sometimes you might see it with this symbol here, this delta symbol that means change. So change in the y over the change in the x. You could think of it like that. So let's go down to number 7. It says, if you were to connect the points 1 and 7.7 and 5 and 18.10 on the graph with a triangle, it would look something like this. Label the coordinates of the 2 given points on this triangle. So this would be the 1 and 770, and this one up here would be the 5 and 1810. How much more distance was added to the ride going from 1 to 5? Four miles. How much cost was added to the ride going from 770 to 1810? So 1810 minus 770. is $10.40. And it says label that on the triangle. So this right here is $10.40. Change vertically. Find the slope of the line using your answers to question 8 and 9. So M, we give it the symbol M, which is our slope, because we're going to use that M when we write our formal equation that we're going to be using. So this would be $10.40 over 4 miles. And when we divide that out, we get $2.60 per mile. It's our slope. How much would 4 miles add to the cost of a tax ride? Would it matter if the change was from 1 mile to 5 miles, or if it was 20 to 24? So 4 miles at $2.60 would be $10.40 more. And it doesn't matter. It doesn't matter where you add the miles. The thing that makes a line is the fact that the slope never changes. It's a constant addition. We now know that the slope of a line describes the rate at which the y coordinate changes compared to the x coordinate. Based on this, how can you decide if the relationship between the two quantities might be modeled well by a straight line? If the slope is the same between all coordinate points. Estimate the distance of a $16 cab ride. You can use either the table or the graph, but make sure you explain how you got your answer. So a $16 cab ride, estimate the distance. So a $16 cab ride, I'm going to say, I already know I have to pay that $5.10 beginning fee. I'm going to subtract that away. I have to pay that no matter what. So $16 minus my $5.10 initial fee. So now I have $10.90 left to spend. And I'm going to do some guess and check. $2.60 times 3 miles is $7.80. So 3 miles is $7.80. And 4 miles is $10.40. So I can go 4 miles because $10.40 plus $5.10 is $15.50. So I'll have 50 cents left over. Yay, that was fun. We practiced some graphing so far. We talked about the y-intercept where we cross the y-axis, and we learned how to calculate slope, and that wasn't too painful. So we're going to look at another problem. But this is all about value of a car. It says everyone knows that after you buy a car, in most cases, its value decreases as it gets older. Suppose you bought a used car for $15,000 a few years ago, and its value has been decreasing at the rate of $2,000 per year since then. Make sure you answer each of the remaining questions with a full sentence, with punctuation and everything. Okay, so here are our time and our values, and here is the graph. Okay. It says find the y-intercept of the graph and explain what it means. Remember, the y-intercept is a point, not a number. Okay, so let's go find it. So here is the y-axis. And we said that the y-intercept was where we crossed the y-axis. So it's that point right there. And I would have to estimate if I only had the graph, but since I have that point in my table, I can mark it right here. So it's at 0 and 15,000. So 0 and 15,000 and what it means. So whenever you have to explain what it means or the slope means, I want you to basically give me a sentence with a who, what, when, and where. So the beginning sale price of the car was $15,000. So my 0 is represented by the word beginning because that's my starting value. And I talked about that was a sale price of a car, and I made sure I had units on the dollars. Find the slope of the line and explain what it means. In particular, what's the significance of the sign? Okay, so the slope of the line, I'm going to pick 2 points. So I'm going to pick 1 and 4 again. Just like I did in the last example. Those are 1 and 4. Okay, so again, I have to take a difference in my second value, second coordinate. So 7,000 minus 13,000. And notice this, I didn't just pick largest minus smallest because they kind of go opposite this time. So I chose 7,000 minus 13,000. So I have to be accurate and go 4 minus 1. Because if you notice, my 4 and my 7,000 still go together as a coordinate, and my 1 and my 13,000 still go together as a coordinate. So when I subtract, I get a negative 6,000 over 3. So it looks like I have a slope of a negative $2,000 per year. So it means the car is decreasing, because I'm using the word decreasing to replace the negative. The car is decreasing in value by $2,000 a year. Estimate the value of the car after 42 months. Everything we looked at so far has been in years, right? So I need to put this in terms of years. So 42 months, I'm going to do a little unit exchange for my practice from unit 1. 1 year is the same as 12 months. So we have 42 divided by 12. So not quite 4 years, right? But 42 divided by 12 is 3.5 years. So my car is started at 15,000, and every year it's going down $2,000. So 3.5 times 2,000 is $7,000. And if I started at 15,000 minus 7,000, it looks like at 3.5 years, I should be valued still at $8,000. And I'm going to just look on my table. So between 3 and 4, if I go up, it does look like I'm at 8. So I estimated, I did that correctly. So that's 3.5 years. Number 17 says, estimate the number of years it took for the car to reach a value of $6,000. So I'm going to use my graph this time. I'm going to go with 6 is between 4 and 8. So I'm going to Just draw a line over and estimate there, and then bring it down. I'm going to say about 4.5 years. Approximately 4.5 years. And I think that looks right too, because if I look at my table, it's going down by 2,000 every year. So that means every half a year, it should be about 1,000. So it says, give a description of how to find the slope of a line and why it represents a rate of change. And let you come up with a good description, and give a description of how to find the y-intercept of a graph and the x-intercept as well. Include a definition in your own words of what the y and x-intercepts of a graph are. So the y-intercept we talked about is the point 0, y, and it's usually our starting value. And the x-intercept is the x value when the y is 0. And so this would be the year for our example here, the year in which the car has no value. Yikes. We don't want that to happen. And our starting value was 15,000 for the car. And then it says, give a description of how to find the slope of a line and why it represents a rate of change. The slope is our change in y over our change in x. And it represents a rate of change because when we divide, we get a unit rate. So that's pretty cool. So that's the end of lesson 2.3. Catch me back for 2.4.